Okay. The solution to the triangle dilemma. I did a reverse image search on Google and I found this guy. Apparently, his name is Presh Talwalkar. Presh Talwalkar. Having the name spit, I'm not going to make fun of his name. So, anyways, he has this video. He doesn't tell you anything, even though it says that you're going to get the solution in the video. The video sends you to a blog where you got to read all about how he's written some books that he wants you to buy, and he's got a Patreon you can join, and all this kind of stuff. Y'all can go check it out if you want to. He says, this is a visual puzzle. Before are two figures decomposed into smaller shapes. Why is there a missing square in the second figure? Then you get this. A mathematical excursion. I'm going to really screw this name up. I'm going to try like Fibonacci. Remember the Fibonacci numbers. The sequence starts out with the numbers 1 and 1. And then each subsequent number is the sum of the previous two numbers. The next numbers are 2 equals 1 plus 1. Then 3 equals 2 plus 1. Then 5 equals 2 plus 3, and so on. The sequence is 1, 1, 2, 3, 5, 8, 13, and so on. There are many interesting properties about the Fibonacci sequence. The one that's relevant to this paradox is a special relationship between the numbers. First, a bit of notation. I'm not even going to go into the number and letter thing. I didn't do very well in algebra, so I'm just going to skip all that part. It's just that one paragraph if you want to read over it, and then that formula that's under it. The formula states that the square of a Fibonacci number is equal to the product of the preceding and succeeding terms plus or minus a factor of 1. Why does this formula matter for this problem? Take a look at the shapes in the figure. All of the shapes have length or widths of 2, 5, 8, or 13, which are Fibonacci numbers. The trick is based on Cassini's formula that, whatever, right there, yeah, okay. That extra 1 is essentially where the missing square comes from. The solution. Okay, so that was just like this detour he took us on through all of that craziness, okay? It doesn't get a whole lot better, but anyway, here's a bit more of an explanation. The top triangle is a true triangle with a height of 5, length of 13, so its area is half of 13, 5, whatever. The bottom triangle is not really a triangle. It is actually close to the area of half of an 8 by 8 square, with one square removed. The problem utilizes the fact that 8, 8 is one less than 13, 5, which is what makes the optical illusion convincing and difficult to detect. In the following figure, the two shapes are joined to make a square. The upper left shape is a true triangle. The bottom shape with the missing square is a fake triangle. The two triangles are shown next to each other. The bottom triangle is not really a triangle. The missing square is just an optical illusion. Okay? I hope y'all are following this better than I am. And this is probably the 10th time I've read this. In between the two figures is a small sliver of area. It's very small, so it's hard to show graphically. This area, which is shaved, is the reason for the missing square. Okay, now, is he talking about that big gouge in the middle coming out of it that he's calling a sliver? Because I can see that just fine. I hope y'all can see it. In conclusion, we're already to a conclusion. Yeah, it's like, in conclusion, like as if he's already told you something. Because I don't know, he ain't told me shit yet. In conclusion, the missing square is not really missing at all. It's just the circumstances create an illusion of a missing quantity. And then, you can also buy his book. Okay. Get the fuck out of here. What the hell? It's an optical illusion. An optical illusion. Okay, now, let me take you back to the one that we were looking at, okay? Now, I redid some of the printing on there because it was real small and kind of hard to see. Okay, the original says, the important part here, the partitions are exactly the same as those used above. It says that by the bottom triangle. The bottom fake triangle. I put on there the parts are the same size as above. Well, apparently that's a lie. How can you create a puzzle and the clues that you give someone to solve the puzzle are lies? We did figure out that they weren't the same, but I'm gonna tell you what. I've had this picture and looked at it on and off for the past like 15 years, and yeah. So I just assumed that with it saying the parts were the same, I always assumed before that they were. But then it was after I put it up and I got to looking at it, it was like something don't really look right. Yeah, so they just lied. Okay, it's not an optical illusion. It's a lie is what it is. So, yeah, so then that's the solution to the puzzle. It's a lie. I wouldn't even call it an optical illusion. What bullshit. If you want a simpler solution to that. Okay, Donna says, Donna's Crafty Creations, she says, I drew out a grid on half-inch squares of 13 across and 5 high, and drew a diagonal line to replicate the 13 by 5 square, triangle. Well, actually 2.5 by 6.5. Donna, those are not Fatoussi numbers or whatever they were. That totaled 32 squares, filled in to some extent with the shapes available. Next, I grouped each set of colors, copied them, and rearranged them as shown. The results in 33 squares, that pesky extra one, which I guess compensated for the bent hypotenuse. See that? I've used that twice now. Or hypoteni. When I overlaid the second figure with the first, there were overhanging pieces, which I then divided and measured each one of those extra bits. Yep, you were right. They add up to the same amount as the space in the extra square. Oh, and see, she did catch on to the fake triangle business. She says you can't make a true triangle from the parts in this problem. Yeah, that's because it was a lie. It was all a lie. So now I'm going to throw a wrench in that whole thing. On a piece of graph paper on the computer, I made a triangle that was shaped like a true triangle. It had straight lines, all 3 of them. And the lines for the pieces inside it, those were all straight. And everything was at the same angle. And I did the same puzzle thing with it and got the same result as the one with the crooked lines. So I'm not real sure what that means because it shouldn't have worked out like that. But I'm gonna say maybe it was the difference in the triangle, because it's hard to get it exact. But I put the overlaid one triangle over the other to make sure I had the same size, and I don't see how it could have been anywhere near close enough to be off by a whole square. But I don't know. Maybe. I don't know. All I know is I have been butt diddling this triangle all damn day, and I'm done with it. I've had enough of the triangle. But here's something to think about. Okay, I'll give the answer to this one next time I put up a video. If you've got a bucket of water, and say your bucket of water weighs 20 pounds, and then you've got a fish that weighs, we'll say 1 pound, and you put the fish in the bucket of water, now how much does the whole thing weigh together? Think about that. It's a trick question, of course, but it's not a lie. So I'll give you the answer next time I put up a video. And Diane and Randy, drop a bitch a link. I want to talk to y'all about that Valentine's Day thing. I'm still waiting. What you scared of? The truth?